All right, welcome back. Today on the bench, we've got the 6-phase NerdQaxe. It doesn't autofocus. But 6-phase NerdQaxe, 3.1, whatever. Not sure who says Bitronix on it, but I've seen a lot of companies, Chinese companies that make these, leave Bitronix logo on their devices when they make them. Don't know if that's the case here or not. I'm not certain. I have no idea. I see some print defects in the screen print, but I have no idea. Anyways, customer's complaint. Blown fuse, likely VR shorted. So let's take a look on the bench here. That's a nice crooked component there. Nice crooked cap. Not a big deal. Even if those were to be connected short together, it wouldn't matter because these are all on the same plane, so it doesn't matter. Okay, so let's go through the troubleshooting process. First and foremost, I want to talk about this because I think this is really important, because I get this question a lot, or I get people that, you know, say different things, blah, 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 and I want to make sure that we clear the air on this so that everybody understands. Okay, this device got a good display on it. Plug it in, power. Nothing. Board is dead. Doesn't do anything. Okay? Leave it on there for a second. You see, display is not doing anything. Okay? Unplug power. Unplug USB-C into the display. What you're going to see is the display fires up. So all of these Nerd devices, every single one of them, when you plug in USB-C, they will power through USB-C. And what's going to happen, it's going to go through its startup sequence. As you can see on the display here. Here, I'll try and... Let's see if I can get... I can't really get this microscope much further back. But what's going to happen is it's going to say PSU fault. And it doesn't matter if I have this display sitting on the board or I don't have this display sitting on the board. The display is looking to see if we have communication with the TPS chip, if we have voltage. It's actually talking to the TPS chip, but it's looking for mains voltage coming through from the main power plug. So it's going to say PSU fault. I don't even have a PSU plugged in. Okay? I'll take the display off. And I expect the same exact result. It's going to boot up. It's going to go through its startup sequence. It's going to send voltage into the chain. It's going to do all different kinds of things. It's going to look for things before it says, okay, we need to turn on. One of those things it looks for is TPS. It's looking for voltage and put an output. And when it doesn't see it, it's going to throw a PSU fault. Okay? PSU fault. Guru mediation, FFFFFF. Anyways, this is really important to understand. Okay? So if I have my device at home and I come up and I have my power plugged in and my board is dead and I plug in my USB-C because I think I can read the logs while it's connected like this, then it must tell me what's wrong. It's going to go through. It's going to go through the startup sequence just as we would normally expect. PSU fault. So PSU fault can be a little misleading for some people, but understand what this means is that the controller is not seeing power. The TPS controller is not seeing power. The system is looking for certain inputs and outputs of certain components and it's not seeing it. This doesn't mean that the PSU is bad. Okay? If we break out our meter and we take a look at the voltage input and output from our power supply, positive and negative, we're going to see that our power supply, and you guys can't see this, but our power supply is at 12.59 volts. PSU is not faulted. The fuse is blown, so that voltage isn't making it all the way through TPS, but it's not faulted. So I want people to understand that when you have when you plug in your USB-C, you're powering that display, and you're gonna see PSU fault in this scenario, this situation, because the fuse is blown, okay? If the fuse was not blown and we had other problems, let's say that the board saw something, it didn't like in a sequence, and it turns the TPS off. You're gonna see either overcurrent protection, PSU fault. There's really 3 codes: PSU fault, overcurrent protection, and overheat, minor overheat. V-REG overheat, there could be a 4th if it's a ASIC, but I'm not sure if I've ever seen that one. But they're very generic. They're reacting to what the system is telling it. So, in an overtemp, it knows when it sees a certain temperature, the software says, hey, shut down TPS, kill the main voltage to the ASICs, throw this error message. That's great. I've seen cases where we get current overprotection, okay? I've seen overtemp and current overprotection be caused by main heat sinks not mounted properly, right? Not getting a good flush contact on ASICs. But I think this is really important to explain to people that PSU fault can really come from a lot of different things. I can not have a blown fuse, but have a bad TPS chip. It's going to throw a PSU fault because it's not seeing output voltage. It's reacting. The message is reacting to a condition it is seeing, but it's making an assumption. So it's very important that people understand that. So overcurrent protection, overtemp is probably a little bit more reliable, just because it is monitoring the temperature of the V-REGs and the ASIC, and if it approaches that temperature limit, it's going to trigger an overtemp and shut down the TPS. But ultimately, all of these codes, like current overprotection, over temperatures, they're all going to trigger the TPS to turn off. And in the logs, you will see, in red, you'll see a TPS 546 with codes, with a bunch of information that you can send to ChatGPT, and it'll help decipher what Texas Instruments says is the condition that caused it. It's not super helpful, I'll tell you right now, because a lot of it's pretty technical. So, for somebody who's trying to figure out what's wrong with their miner, that's not a lot of information. But PSU fault, just understand what that means is that the TPS is seeing condition. Now, if, like here, where I've got it unplugged from the USB-C, I haven't unplugged it, but I've got power still connected, I don't see anything on the display, it doesn't necessarily mean that my PSU is bad. It could be. It's more rare of a situation. I'm looking at fuse, I'm looking at something else that's a problem. In this case, the fuse is blown, and we're going to look at why the fuse is blown on this. But again, if I plug this in and I go, okay, well, do I have a bad display? What's wrong? No. Look, take your power off. If I plug in the USB-C again, it's just going to power on the display. It's going to say PSU fault, but as we've looked at it, it's not a PSU problem. So don't assume magically that your PSU is bad. Okay, there's lots of reasons why we would get a PSU fault, especially if the miner's been running. If we have the main power plugged in and we see the miner's been running, and we come up and we see PSU fault, or we see, overcurrent protection, stuff like that. The power supply is providing power. The display is powered up. It's getting the power that it needs to be powered up. The last place I would be looking is the PSU. Again, it's not that they don't go bad, but it's really important to understand the difference. So in this case, this customer sent this to me. It's got a blown fuse. It has a short on the main power rail. And in another video here, we're going to discuss what's wrong with it. We'll go through and we're going to fix it up, and we're going to get this guy back up and running. But I wanted to be clear so people understand the error messages on the screen are there to help try to provide some kind of guidance. But PSU fault doesn't mean that the PSU is bad. The PSU fault means that the TPS is not seeing, or the controller is not seeing, the voltage it wants to see, and there could be many reasons for that, okay? Again, if I plug in a miner and I get, it goes through its motions, it's doing its thing, and then I get a PSU fault, but my display is still lit up, my PSU is there. Now, again, there's other things we would want to look at. Is the voltage dipping below where the controller wants to see it? Is there another heavy current load that's drawing on it that is bringing that PSU down? That's all possibilities. But don't just immediately leap to, hey, I got a bad PSU. In this case, I don't. This is a totally solid, great PSU. But as you can see, I can replicate the way these errors are. It's it's just really important to understand that if I plug in a USB-C to this little LEGO display, regardless of whether it's plugged in the board or not, it will power that board up. I will be able to get into the dashboard on my website. I can look at everything I need to look at. It's just not going to mine, and I'm going to see PSU fault on the screen, period, no matter what. So wanted to share that information, get some of that information out there. I'm sure you guys have lots of questions. Feel free to comment. But there are essentially, from my understanding, from what I've seen, three, maybe four codes that I see: overcurrent protection, PSU fault, V-REG over temp, and I possibly ASIC over temp. I just don't know if I've seen that or if it just says over temp. I can't remember. It's a rare occurrence when I would even see those V-REGs happen, but those cases. And essentially, temperatures I trust more because the firmware is actually monitoring the temperature inputs, and it sees that temperature, and that's a pretty easy, clean-cut way to say, hey, we've got a problem here, and it sends a signal back to the controller and says turn off. But I've seen overcurrent protection and overtemp conditions both caused by improper mounting of heat sinks. Okay, so just something to keep an eye out for. You don't want, and we'll talk about it in another video on how to properly mount heat sinks to the ASICs, but you certainly do not want to over tighten them. It's a good balanced all four corners, even, I would say, light pressure. I usually tighten it with just my fingertips. Boom, 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 all four corners, that's it. I don't crank on them. You don't want to do that. You don't want to flex the board so much that you actually break the contact between the ASICs and the board. And on some of these cheaper made, get what you pay for copies of these miners that are made with really thin boards and really cheap. I mean, there's a reason it's cheaper, guys. I'm going to tell you right now, there's a reason it's cheaper. And as many that come across my bench, I can tell you for certain that they cut corners in thickness of boards, amount of copper that's in the boards, and when they do that, they flex more and more. And you get a big board like this, okay? You get a big board like an NerdQaxe, and that is just basically like a sheet of paper flexing. You tighten up too much on these things, and they just flex. Now, this is Victronics. I typically find the Victronics ones are better, but there is one supplier that every single one that has come across my desk has had one or more, or in some cases, up to 7 cracked ASICs because of board flex. So, buy reputable, be careful. So I wanted to just talk about the display codes and kind of show you the way that it works on a broken board. Again, I can plug in USB-C. It's always going to power it on whether the board's good or not. And it's always going to say PSU fault if I have no power going to it. If I did have a good board, and we can look at that later, but if I did have a good board here and I plugged in both, yeah, it'll look and act normal. It's going to do its normal thing. But yeah, I just wanted to share that out there because I get a lot of questions, a lot of misconceptions about what some of these things mean. So, got any questions? Hit me up. Thanks.